Welcome to This Is My Architecture. Today we've got Shimon from ironSource Atom. Shimon, tell us a little bit, what is ironSource Atom?
ironSource Atom is a data pipeline streaming events in near real time into a data warehouse like Redshift.
All right, how many events are we talking about here?
Hundreds of billions of events every month.
Awesome. And so what you've drawn up here is a bit of the architecture behind Atom. Do you just want to run us through what we've got here?
So basically, we have customers like e-commerce or gaming studios that want to use our system. So for example, if you have a game, you would incorporate our SDK into your, for example, Unity game, and then you would run a query against Route 53, and you will receive the lowest latency region available. And then you would stream your events, JSON key value pairs, into our system that is backed by ELB and frontier servers that receive the events and then stream them into Kinesis in order to process them later on. So we send it to Kinesis. We use protobuf in order to compress it and make it cost effective.
Right.
And Kinesis is in one specific region. So everything is going into one place.
So you're collecting around the edge, around those certain locations for like low latency collection point, and then condensing that globally into a single Kinesis stream.
Exactly. We call this the transformation layer. And we have worker machines that actually use read the stream and perform different manipulations like IP to country, breakdown of user agent. For e-commerce customers, we do currency conversions, for example.
Right. And so with the workers, say, in consuming, are you using Kinesis Client Library or KCL to do that?
Yeah, we're using the KCL based on Python.
Okay.
This is very easy for customers also to submit custom code in order to do enrichment for their
so
data.
Your customers can actually specify custom code for their workers off their stream.
Exactly.
Right. You got Elasticache at the top here?
Yeah, so actually we're using Redis. So what happens is we don't want to have duplicates in our system because we have customers using it for billing. Okay. So we do cleanup of the data, different manipulations, and also deduplication using Redis.
So state information you're calling in Elasticache as the workers deal with it. So the workers are stateless.
Exactly.
Okay. And then what's happening down here?
And then the workers put the processed files into S3 and they register events into SQS. And then later on, we have the inserter process that actually reads the data off of SQS and knows which files are pending to be copied into which tables in Redshift.
So as the workers analyze this data using custom data from their customers and generate an output file, use SQS to notify the inserter off it goes. Are you looking at Kinesis Streams or Kinesis Firehose to simplify some of this looking forward?
So we're thinking about Kinesis Streams because we're using currently Kinesis Streams, but Kinesis Analytics is something that's very, very interesting to us because it will allow us to use different manipulations on top of the stream. And it's really nice because our customers' data goes into their Redshift in their account. So it will reduce load on their Redshift if they can do aggregations within the pipeline before reaching their data warehouse.
And so this architecture, if I'm playing a game and I'm just started level 3, for example, how long is it taking for an event to get from when I trigger it in the device through to being, as a customer of yours, being able to see that within Redshift?
So usually it takes less than 10 minutes, usually up to a minute.
Right.
It really depends on the different loads of regions around the world, the connectivity between the regions, and the load on the Redshift cluster.
Okay.
So most of the time it's 1 minute, but it can be up to 10 minutes maybe.
Right, okay. And so when you look at this architecture, and dealing with 100 billion events a month, that's a big scale. What's the biggest component of this for you in terms of scaling?
We process more than 100 billion. It's hundreds and hundreds. And the most costly thing is actually the worker here, because this is CPU intensive and it does crunching of the data. And it costs a lot of money because it does a lot of operations, unlike this part, which is mainly I/O bound.
And so it's using EC2 Spot there to optimize the costs of your worker fleet here?
Totally. Spot instances reduced our costs by more than 80% and allowed us to offer a cost-effective model to our clients.
One of the challenges with Spot, though, is you set a bid price. If the spot market actually moves beyond that, effectively it removes the spot instances from that. How do you deal with that situation? What's your fallback mechanism?
So our fallback mechanism is into on-demand instances. We use a partner called Spotinst, and they do this automatically for us. And because we use Kinesis streams, all of the data is backed up in Kinesis. So if we lose an instance, another one goes up and just reprocesses.
And so you're using the features of KCL, the client library, to actually know where it was in that stream. When it restarts again, it can point back exactly where it was.
Exactly. So we use the KCL, and we have Dynamo, which is actually a table, and every worker is checkpointing the state into the Kinesis table. And then if this worker goes down, another one goes up, and it knows where the checkpoint was, and it can continue.
So you talked about you've optimized your Spot instances based on that kind of optimal price point of Spot. When you fall back to on-demand, do you use the same instance size, or do you actually have a different size instance you use in that scenario?
So this is a quite apocalyptic scenario. We almost don't have any revocation using Spot. But if it happens, we fall back to the same instance
Okay,
type.
just to keep it simple and a known point. Excellent. Shimon, thank you very much for sharing with us the architecture behind ironSource Atom. It's been fantastic to see how you deal with the scale of handling hundreds and hundreds of billions of events every month around the world. This is my architecture. Thanks for sharing.
Thank you.